Afternoon, everyone. My name is Mark, and I work with customers around Southeast Asia, working on their legacy applications and how they can start to move and make use and leverage modern cloud-native technologies like containers and Kubernetes. And in my session today, I want to spend a lot more time helping you to understand the latest product that Google Cloud has launched, which is called Anthos, and how Anthos can help you on that modernization journey and make it just that little bit easier for you. So you saw a similar slide that Greg had on this morning during the keynote. Traditional IT is complex. It's hard. Look at the statistics. Statistics never lie, right? Well, statistics aside, many years ago, in IT, we started with things like mainframes. And then we moved on with proprietary Unix servers. And then now we all use majority of servers, x86 servers, which we all love. From a deployment model or configuration perspective, we got converged infrastructure. And then in the past 10 or so years, a new trend of hyper-converged infrastructure. There was also a time when blades were fashionable. But I think that it's kind of gone out of fashion, and now they've come up with a new name called composable infrastructure. How about cloud? I'm sure all of you have been asked to think about how to implement a private cloud in your data center. And the fact that you're here means that you're also trying to figure out how do you make use of the public cloud. For those of you that have already been on the public cloud for a while, have also reached a conclusion that one cloud is probably not enough. And so you're going to need 2 clouds, maybe 3 clouds. And now we have multi-cloud. So if you didn't believe that traditional infrastructure is complex, I think now you can agree with me that it is. Wouldn't it be nice if we had a way to make this all simpler? Let me tell you a story. In my story, it starts off with this, a container. In the beginning, there was a container, and it was good. Containers are wonderful. Containers give you 2 things. The first is a logical packaging mechanism that allows you to abstract away the application from the environment on which it runs. And because of that, you can consistently deploy your applications to different environments, different hardware, and different clouds. The second thing that containers give to you is process and resource isolation. You may not know this, but Google had a little something to do with this almost 13 years ago. So 13 years ago, Google had contributed some code into the Linux kernel called C groups or control groups. And that's what allows containers to be able to have guardrails around the resources that they use within a single host operating system. The best thing about that is that once you have isolation, you get to stuff more processes on the same operating system and the same hardware. And that brings you cost savings. So one of the things that most of my customers that have already embarked on the containerization and Kubernetes journey have realized is that they've all realized significant cost savings compared to when they were still using traditional bare metal or virtual machine-based infrastructure. But it turns out that containers are not really the silver bullet by itself as well. Because once you start using containers, you start using more of it, and then you realize that, what if I want to run the container not only on a single host, but across multiple hosts? How do I decide where to schedule these containers? Do I put it on host 1, host 2? How do I know which host has capacity? How do I monitor the health of my containers? How do I know when to restart them when they crash? You heard about containers helping you to do things like auto-scaling this morning. And you hear a lot more about it later today as well. How do you achieve auto-scaling? What is monitoring your application to know when I should create more replicas of the application? So this is just a sample of some of the challenges that you start to see when you begin that journey onto containers. It turns out that, again, there's already a solution out there. And this is a solution that Google helped contribute back into the community almost 5 years ago now. So the solution is called Kubernetes. And I'm sure most of you have heard about it already today. If you haven't, let me tell you a little bit about it. So Kubernetes is a container orchestration system, right? It helps you to automate all of the tasks that I showed you on the previous slide. Things like figuring out where to schedule your containers, things like monitoring the health of your containers, right? And handling things like load balancing and scaling. But like most open source software, getting it up and running with a production quality is something that is not so easy. Right? Maybe a just quick survey of the room. Let's take a poll. From a scale of 0 to 10, for those of you that have deployed open source software before, where 0 is extremely difficult and 10 is really easy, how would you rate using open source software? Well, let's do it on 3. 1, 2, 3. Right, so just looking at the room, most of you are at about 5 or less. Right, so we all know that using upstream open source software can be challenging. It's the same thing for Kubernetes. What you're looking at the screen right now is already a summary of the tasks that you need to deploy Kubernetes on your own. So if you go to GitHub and you go download Kubernetes from source yourself today, these are some of the things that you need to think about and figure out in order to get your Kubernetes environment up and running. Right? This list of tasks was written by my colleague. His name is Kelsey, and he's a developer advocate at Google. And when you manage to get this done and have your Kubernetes environment up and running successfully, you're going to look just as happy as Kelsey. But again, it turns out there's a catch. Kubernetes is a very fast-moving project. Every 3 months, the Kubernetes project releases a new version of Kubernetes, which means even though you look like this right now, in 3 months' time, I think you look a little bit more like this, because you've got to do it all over again. So what's the solution? That's where Google, almost 4 years ago already, has released our managed Kubernetes product, which is called Google Kubernetes Engine, or in short form, GKE. GKE is a managed Kubernetes service where we have Google's site reliability engineers doing all the hard work of provisioning and maintaining your Kubernetes infrastructure. All of that can be done very simply through our Google Cloud Console and our simple UI, and you have your Kubernetes clusters up and running in no time. But one key word that was mentioned this morning many, many times was hybrid. GKE is great if you're ready for the cloud. What if you're not? What if you still have some applications that need to run on-prem? That's the reason why Google started to move into this space with Anthos. And with Anthos and GKE on-prem being a part of Anthos, that's how we're trying to address the need of our customers of having Kubernetes on-prem in your data centers. So what GKE on-prem is a Google-configured Kubernetes distribution with automated provisioning and managed upgrades. What's really awesome about GKE on-premise is that it connects seamlessly into the Google Cloud. And it looks and behaves just like the GKE clusters that you're used to using on the Google Cloud today. You're going to get a single pane of glass, which looks just like that, so that you can control all of your clusters, whether or not they're on Google Cloud, they're on-premise, or just like we saw this morning, could be running on another cloud. What's more interesting is that because we're using the same Google Cloud Console to manage this hybrid environment, we get to leverage all the sophisticated security capabilities that come with Google Cloud. One of which is called VPC service controls. What VPC service controls allow us to do is to lock down and control access to the Cloud Console so that only users within your organization who are fully authorized and users who are coming from your corporate network and on your corporate device are then able to access the Cloud Console. If not, if it's just your employee or your admin that has gone home and tried to log into the Google Cloud Console, this is what he'll see. So isn't that amazing? You're really getting the best of both worlds. You're getting a hosted and a managed cloud experience with the console. At the same time, from a security perspective, it's locked down and secure, just like your systems today are on-premise. So, for the techies in the room, let's take a little bit of a deeper look into how GKE on-premise is architected. So, Inception. So why did I suddenly talk about Inception? If you look carefully at this picture, you realize that there seem to be 3 clusters, right? And the reason for that is that with GKE on-premise, we're using a design which is called cubeception. In other words, we're trying to use Kubernetes to manage Kubernetes. So when you deploy GKE on-premise, the first thing that you set up is the admin cluster, which you see at the top there. You'll have one of these for every environment, GKE on-premise environment that you need. Once you have that admin cluster up, it then becomes really, really simple to spawn out as many other child clusters or user clusters that you need, right? Making the whole experience of creating Kubernetes on-premise as simple as it is on the cloud today. So what you've just heard about in terms of GKE on the cloud, GKE on-premise, as well as GKE on other clouds earlier this morning, form the foundation of Anthos. Tying them all together is the Google Cloud Console, providing that single pane of glass for cluster management, including our stack driver monitoring service that also provides a single pane of glass for monitoring your environments, your Kubernetes environments across cloud, on-prem, and other clouds. So now's a good time to switch over to the live demo so you can see some of this in action. Okay, so what you see on the screen is the same environment that we had earlier this morning with the keynote. So I have my 3 clusters running, showing up in Google Cloud Console. The first one is running on Google Cloud in the US, right? The second one is the one running on the other cloud, and then the last one here is the one running on-prem. What I'm going to do now is something that I didn't have time to do earlier this morning, which is to show that not only is the Cloud Console just a visibility or read-only access into my Kubernetes environment, I can actually use the Cloud Console to control these environments and these clusters. So what I'm going to do is I'm going to go over to the Applications tab and deploy an application from our marketplace. All right, so I'm just going to choose CloudBees CI/CD Jenkins tool, and we can configure it over here in the console. And already up here, you can see from the cluster dropdown, I'm able to choose either the on-prem or the external other cloud cluster. Right? The console will be able to talk to our agent that's running inside the cluster, and I can find the namespace that I want to deploy into. I will have a host name there. New service account, standard storage, and deploy. And that's it. It's as simple as that, right? So again, this is Google Cloud Console providing that single pane of glass for not only controlling and monitoring your Kubernetes environments across different clouds and on-premise. Okay, so now back to the slides. So now that we've made it really easy for you to create Kubernetes clusters, right? What's going to happen? Just like human nature, your admins, your operations guys are going to end up creating a lot of them, right? And not only are they going to end up creating a lot of clusters, they're going to end up creating clusters with different shapes, different sizes, and if it's allowed for them to create clusters, without properly hardening them or locking them down, without the right network policies or firewall rules, they're just going to go ahead and do that. So you thought that your environment of Kubernetes clusters is going to look something like that, but what's going to end up is you're going to have an environment that looks more like this. So again, what is the solution to this problem? We already got a peek at this earlier this morning. Again, during that very short keynote demo, we saw how we used a product called Anthos Config Management to apply a single policy across multiple clusters all at the same time. So Anthos Config Management is really a key part of the Anthos package that helps you to provide that centralized governance and compliance across all of your Kubernetes environments. Let's look again deeper into how that is actually implemented. Anthos Config Management is essentially made up of two components. The first is having those policies in the first place. So we saw an example of a policy this morning, right? It's a short YAML file. So if you're already working with Kubernetes, you would already be very familiar with lots and lots and lots of YAML, right? The YAML files that are used for Anthos config management are exactly the same YAML files that you use in your Kubernetes clusters today. They just need to be placed in a specific hierarchy, like the example that I have on the screen, and pushed and synced into a Git repository. The advantage of having all of your policy in a Git repository means that you get version control, you get auditing, you get approvals, all built in for the security policies that you want to apply across all of your Kubernetes environments. The second component to Anthos Config Management is what's running inside the clusters itself. So Anthos Config Management will install some of Anthos Config Management Google software into those clusters. And the job of those applications are to monitor the policies that are inside your Git repository, sync it down, and make sure and ensure that all your clusters are always in compliance with the policies that you've defined. One of the new capabilities that we've just added into Anthos Config Management just probably 2 to 3 weeks ago is something which is called Gatekeeper. So not only can you define policies that you want to apply to the cluster, you also now have a component that's running in your Kubernetes environments as a gatekeeper, checking every single resource that any of your operators or your CI/CD pipelines are trying to push into your cluster. So just as a simple example, if you wanted to ensure that all resources running in your Kubernetes environments have a label so that you can trace back to who owns those applications, you can write a gatekeeper policy that says, do not allow anyone to start an application inside Kubernetes unless they have a proper label defined. All of that is all part of Anthos config management. So let's zoom back out again to Anthos. And we've now seen how Anthos config management provides the second key component of centralized policy management across our environments. The last thing that I want to cover today is about services. Just like how we were talking about the proliferation of Kubernetes clusters earlier today, organizations are starting to see a move from more monolithic application architectures to more microservices type architectures. And what happens with that transition is that we're going to see a lot more microservices and applications running within our environments. No more are our enterprises having an inventory of maybe hundreds of applications across the enterprise, but it will start to become much larger numbers into the thousands. And this is what I've already seen at many of my customers adopting containers and Kubernetes. But microservices are really, really hard. How do we understand all the dependencies between the microservices? For a single request that's coming from that user, how do you know how many microservices it has to traverse in order to respond back to the user? How do you handle security? So previously, when we had monolithic applications and just one application server, maybe a Tomcat server, maybe a WebLogic WebSphere server, right? The function calls between the modules all happen within that one application server in memory. Now that we've broken it down into microservices, those function calls are now happening across the wire. What are we doing to keep that secure? How do we go from a mess like this to an organized and structured hierarchy of services? The answer is Istio as an open source tool and Anthos Service Mesh as Google's managed implementation of Istio. A service mesh is a network that's designed for services and not bits and bytes. A typical layer 3 network doesn't know what application is running over the wire, right? It doesn't know where those bits belong to. So what does a service mesh do for you, your application, and your operations? Essentially, a service mesh provides three things. The first thing that a service mesh does is it provides intelligent routing. Think of a situation where you have a current version of an application, and your development team wants to push out a beta version of this new application. But they don't want all the users to be going to that new beta version. What a service mesh allows you to do is by writing a simple policy, say something like, only send users who have signed up to be a beta tester and redirect that traffic to the new beta version of my service and have both those versions of my service running concurrently within the same mesh and the same cluster. This is the way that all the digital cloud-native companies operate and allow them to do continuous deployment and zero downtime upgrades of their applications. The second thing that Anthos Service Mesh does is around security. And we already saw how that works this morning. Again, with the application of one single policy, we were able to ensure that all the traffic between two services in the mesh are fully encrypted with mutual TLS, and authorization is enforced. so that only services that have been explicitly allowed to talk to each other are able to send traffic to each other. And the last capability that the service mesh provides is observability into your services. And for that, I'll have one more demo to help you see how that works. Okay. So this is the Anthos Service Mesh GUI. And what we were looking at this morning was the topology view. And now I've moved into the table view, seeing all the different services that make up that wonderful e-commerce online boutique application that we saw this morning. Clearly, there may be something wrong with my application. As you can see, there is a red exclamation mark there. So let's try to have a look and see what's wrong. If I click on that, immediately I'm told that I don't seem to be meeting my service level objective with my front-end service, so I better investigate why is that so. Let's have a look at the Health tab, and we can see that we actually have already defined a service level objective of 99.9 availability for this service. Right? So that's one more thing that Anthos Service Mesh allows you to do, is to operate your services and your applications in a similar way to how Google does, setting service level objectives and service level agreements on all of our services and monitoring to see that they're always meeting those objectives. So we can see that our current availability is around 92%, which isn't great, right? So about 7% of our calls to our front end seem to be failing. All right, we need to dig deeper. We need to find out what's the root cause. Let's have a look at the metrics to see if we can find some clues. So again, with Anthos Service Mesh, without having to instrument your applications with additional agents, etc., you automatically get all of this telemetry data just by running your applications on top of the mesh. We can see how many requests per second. We can see that clearly we do have errors being returned. We can see the latency of our application and the size of the request. Right? But I still don't have the clue of why that's happening yet, so let's have a look at the Diagnostics tab, where we can also look into the logs that are coming from our application. So all within the same interface, we're now able to have a look at the application logs and see if we can find some clues. So clearly something's wrong there. We have an error. Let's click on this link here to go into our stack driver logging GUI and look deeper into the logs. So if we look here, we can see that there was a failure. It seems to be something to do with a credit card not being able to charge the card because it has expired. That's a bit strange. If you're looking here, it looks as though the code is a 400 error, but I seem to be picking up 500 errors in my monitoring. So let's try to look for more clues. I'm going to look for more log entries from the same HTTP request. And here we go. Collapse all. Let's look at the final log and see if we get any clues here. And there you go. So it turns out that even though the application is actually experiencing a 400 error, so it's something to do with business logic, it's returning a 500 error instead. And that's why my monitoring system is saying that I'm not meeting my SLA. So as someone that's working in ops, I think this is the time that I email my boss and say, hey, guess what? It's not my fault. All right. OK, so back to the slides. So that was the last piece of the Anthos puzzle, right? With Cloud Anthos Service Mesh providing comprehensive service management across your entire platform, all the applications, whether they're running on the cloud, on-premise, or on other clouds. One last thing I wanted to say before I wrap. there is still something more of which Anthos brings to the picture. So on top of everything I covered today, Anthos also includes an enhanced version of GKE, or Google Kubernetes Engine, which is called Anthos GKE. And that brings additional capabilities like what you've seen, again, this morning in the keynote with Cloud Run for Anthos. It also brings additional, more sophisticated scaling, auto-scaling mechanisms with vertical pod auto-scaling and cluster auto-scaling, as well as node auto-provisioning, which is what you see in the bottom left-hand corner, right? On the security side, we are now providing something called sandbox pods, as well as binary authorization for software supply chain security. To find out more about all of these capabilities, please come back to this session, I think at around 2 plus p.m. For the session that my colleague Wong will be going through. So, in conclusion, what does Anthos bring for you? Anthos is based on open source technologies, allowing you to have a consistent and portable experience for all your applications as well as your operations. Anthos with GKE on-premise is then able to allow you to modernize your applications while staying on-premise if you need to due to regulatory or other reasons. And lastly, Anthos allows you to manage your applications as services and not infrastructure, right? With an intelligent service mesh that allows you to operate and run your services optimally and securely.